Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to the Electrical Engineering channel. In this lecture, I will discuss power system automation and SCADA. So, power system automation is necessary to achieve optimal use of electricity, and it will provide us automation in generation, transmission, distribution, and utilization. The important parts of power system automation are intelligent electronic devices, Ethernet-based communication, standardization of communication protocols. So what is SCADA? SCADA is basically the abbreviation of supervisory control and data acquisition, and it involves collection of equipment that will provide an operator at a remote location with sufficient information to determine the status of particular equipment or a process and cause actions to take place regarding that equipment or process without being there. So remotely, any part of a power system can be monitored and any command can be given to that equipment for getting the desired output. And there is no need to be at the place of the power system equipment. And remotely in a control room, the power system operator can monitor and command the power system to get the desired result. So, data acquisition and supervisory control of the process. These are the two main tasks of a SCADA system. Automation leads to a control room to see the remote process on operator console, complete with all the information required, displayed, and updated at the appropriate time intervals. So it collects the data from the field, converts the data into transmittable form, which is a discrete or digital form, bundle the data into packets, transmit the packets of data over the communication media, receive the data at the control center, decode the data, and display the data at appropriate points on the display screens of the operator. Automating the control process will ensure that the control command issued by the system operator gets translated into the appropriate action in the field and will involve the following steps. So these are the steps, and you can see here we have a master station computer system. There is a communication channel, and any command which is generated over here will propagate through the communication channel, and that information will be a digital information. So here we will have interface devices which will convert digital data into the analog data, and the controllers and actuators will receive that analog data and take the necessary action in the power system. So power system can be controlled. And similarly for monitoring, the data from the power system is actually an analog data, for example, temperature, pressure, humidity, and so on. So that data is actually sensed by the sensors and transducer relays, and that analog data will be converted to the digital form, and that digital data is transmitted through the communication channel, and that communication channel will take the data to the master station computer system. So this is a bidirectional information exchange system which is actually implemented in SCADA, and this will give us the complete control and monitoring of the power system. So the operator initiates the control command, bundle the control command as a data packet, transmit the packet over communication media. The field devices receive and decode command. Control action is initiated in the field using the appropriate device actuation. So these applications of SCADA are a large number of industries for monitoring and control. For example, oil and gas industries, pipelines, undersea and continents are monitored where flow, temperature, pressure, leakage are assessed and controlled. Right. Water treatment, distribution, waste management use SCADA to monitor water levels, remote and lift station pumps and chemical processes. Heating, ventilation, air conditioning. So all of these industries use SCADA systems for these purposes. And steel, plastic, paper, and other manufacturing industries use SCADA for quality products. Mining industry, tunneling, product flow optimization, material logistics, worker tracking, and security features. So they are also ensured by SCADA system. And for studying SCADA system in detail, I will recommend you this book, Power System SCADA and Smart Grids, by Minnie S. Thomas and John D. MacDonald. So that is all about the brief discussion on SCADA systems. Now we will discuss the types of data and signals. First type is the analog signal, and analog signals actually use voltage transducers, and voltage transducers have 4 to 20 milliampere output, and the current output is preferred for transducers due to ease of transmission over long distances and less distortion due to interference. So current transducers are better preferred, and if we have zero power, it means we will receive a current signal of 4 milliamperes, and meaning that there is a broken line. For example, if we have a transmission line and at the receiving end, if we are receiving 4 milliamperes, it means there is zero power which has been received, and that zero power can be due to a broken line at any point in the transmission. Okay, so this you can observe in this figure. Here we have power and here we have current signal. So zero power means 4 milliampere, and any other intermediate value of power will correspond to the unique value of the current. So A to D conversion is very important in industries, and in A to D conversion, these steps are followed. So the signal from the process is actually retrieved by the sensors and transducers. That signal is amplified, and we know that if there is some noise in the signal and we are amplifying that signal, it will amplify the signal level as well as the noise. So that noise has to be filtered out. So we have a filter over here which will filter out the noise, and only the useful information will be available. So then that useful information is sampled and A to D conversion process is applied so that we get the digital output. So this is the whole process of analog to digital conversion. Another very important part of a SCADA system is remote terminal unit, which is abbreviated as RTU. And the features of remote terminal unit are internal computational and optimization facilities. It collects data from field devices, processes the data, and sends to the master station over communication system to assist monitoring. Right, RTU also receives control commands from master station and transmits to the field devices. So it collects the data from the field devices and it transmits the data to the field devices from the master station. So both these tasks have been handled by RTU. So you can see here we have a master station, and this is a human machine interface based system. Here there is a communication channel which will pass the information to the RTU, and RTU is interfaced with the field equipment. So it can transmit the data to the field equipment and it can get the data from the field equipment and propagate through to the master station. So RTUs or the remote terminal unit is actually the old component or old technology. Currently, the modern SCADA systems use intelligent electronic devices. They are more efficient as compared to RTUs, and they actually work in groups. And you can see the same master station can be interfaced with the intelligent electronic devices. There is a data concentrator in between IEDs and the master station. So that data concentrator actually collects the whole data and divides the data into different packets and send those relevant packets to the concerned IEDs. Those concerned IEDs actually communicate with the field equipment. So these are also the components of the SCADA system. And here HMI corresponds to human machine interface. FEP is front end processor and CFE is the communication front end. So these abbreviations will be used in the coming block diagrams and status point data acquisition. This is the circuit diagram of this technology. Here we have 220 volts and we have two switches, right? There is a coil and that coil will be coupled with this coil and we have electromagnetic coupling in between them. This is open or closure indicator and here we have RTUs, right? So you can see that there is an electromagnetic coupling. That electromagnetic coupling is actually used to get isolation between the excitation system and the RTU side of the SCADA system. There is must be an electrical isolation, so that's why electromagnetic coupling has been used. And these RTUs actually receive the signal or the voltage signal from this coil. Okay, and data flow from field to the control center can be understood by this block diagram. And in this block diagram, you can see we have a bus bar voltage, which is a high voltage of 220 kilovolts. Then we will have a potential transformer which will convert this high voltage to the low voltage of 110 volts. And these 110 volts are converted to 4 to 20 milliampere signal by using a voltage transducer. And here we have conversion of this analog signal to the digital signal and packaging of that data. And that packaging of the data has been communicated with the RTUs, and these RTUs will communicate with the control room. Okay, and in the control room, we have a master station and a computer operator or a power system operator, which will monitor all the actual information in the power system, right? So these are the protocols, communication front end and the front end processor, right? These are communication protocols, and you can see that uh, the operator in the control room will be getting that high voltage information in the centralized control room, and there is no need to send any personnel to visit and measure these high voltages, which are very dangerous. So this SCADA system and remote processing of the power system also ensures the personnel safety, reliability, and efficiency. So data transfer from bus bar to SCADA control room. So that is actually explained in this block diagram, and that is all about our today's lecture on the introduction of SCADA systems. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.